this problem is actually very easy, but I'm going to show you, hopefully, I'll convince you of a quicker way to solve this versus maybe graphing it or even doing it by hand. Okay, so what does this say? X minus 2 is square root of x plus 10, which of the following values of x is the solution to the equation above? Okay, so before I go into solving this, let's quickly review. When we solve radical equations, there could be extraneous solutions. And why do they come up? Okay. So what am I saying here? I did not reread my slides beforehand. So solving that equation, this is the equation, is the same thing as finding the points of intersection of y equals x minus 2 and y equals square root of x plus 10. So if we graph them on the digital SAT now, you can totally graph them. It should always allow a calculator, I believe. So you can graph them, find the point of intersection is x is 6, y is 4, okay? Totally fine. So why do extraneous solutions come up? If you do it algebraically by hand, what would we do? We would square both sides. So we would get x minus 2 quantity squared is the square root and the square cancel, so you're left with x plus 10. So if you want to go backwards, actually, I think that's my next slide. Okay, so if we graph this over here, this parabola and this linear line, look, now there's two solutions. So what happened? There's one at the same value of x, which we expected, but now there's another one that x is negative 1. Okay? So what happened? Why did it go from one solution to two solutions? Well, let's look at this graph over here. This is the square root function. This is the linear line, okay? So algebraically, what's happening is, well, if you try to go back from this line, when we squared both sides, if you square root it back, what do we get? We get x minus 2 is plus or minus square root of x plus 10. You now have this plus or minus. So instead of just one side of this sideways parabola, you have this bottom half as well. So that's where the x is minus 1. See? That's where the extraneous solution appears. When you square both sides, you could possibly open up this other branch over here. Depends on the shape of the parabola and the line, but this is an example of what happens, okay? Just to review. Okay, so if we solve it by hand, that's what I did down here. We would square both sides, so you would get on the left-hand side, if you FOIL out, it's x squared minus 4x plus 4. Right-hand side is x plus 10. We move everything to one side. We want to set it equal to 0. So you get x squared minus 5x minus 6 equals 0. Now, if you factor, it's x minus 6, x plus 1. So x is 6 or negative 1. Okay, which we saw. 6, negative 1, yeah? Okay, and what do we do when we solve these types of equations? We obviously have to plug back in to check if there's an extraneous solution. So if we plug in x as negative 1, you get negative 3 equals square root of 9, which is not true. So that's why it's extraneous, okay? So solving it by hand like this would be the slowest way to solve this problem. Graphing it would be slow as well. Even though it's faster, I would say probably twice as fast as doing it by hand, or more, but it's actually slower, I would argue. Instead, let's just plug in these values and see if any of them make sense. If you plug in negative 1 onto the left-hand side, you get negative 3. Okay, can a square root output a negative number? No, cross that out. How about when we plug in 1? You get negative 1. Can square root output a negative number? No, we just already said that, right? So cross out B. You should be able to do these quickly in your head. How about plug in C? We get 2 is square root of 14. Well, square root of 14, I don't know how to simplify that. Cross that out. D, it would be the answer then, but let's check. 4 is equal to square root of 16. True. Okay, so again, my point is you could totally solve it by hand, or you could graph it, but it comes from experience that you could just start eyeballing some of the answers to see if any of them totally don't make sense, like A and B. It would be a negative number, and you know a square root cannot output a negative number. So we cross those out, and then you only have two choices left. Might as well just plug in. All right, so hopefully here's a tactic that shows you, you can see how we can be smart about these problems and not have to solve them or graph them every single time. It's these types of problems that are good to see if you know these concepts very well. And you can get them quickly and save your time on this to solve some harder ones. more carefully.